Today we'll try to solve a problem using a software called as Arena. Arena is a discrete as well as continuous event simulation tool. The problem taken here is a one pump gas station has two types of customers, police cars and regular cars, arriving as a Poisson process with a mean of 2 and 11 cars per hour respectively, with the first police car arriving at the 15th minute and regular car arriving at minute 0. Service time at the pump are exponential with mean 4.3 and 5.7 minutes respectively for police and regular cars. Cars join the end of a single queue if the pump is busy. However, a police car arriving at the busy pump goes ahead of any regular cars in the queue. Simulate the system for exactly 500 cars to complete the service and estimate the average delay in queue for each type of car separately, expected number of cars of either type in the queue, and expected utilization of the pump. Now, trying to solve an arena, we need to go to discrete processing where we have different modules which we can use to solve this particular problem. Any arrivals can be created using a create module. So for that reason, I'm just dragging here the create module, and when we double click the create module, a dialog box will appear and I can give the details here. Here, I just call it as a create police cars. That's the arrival of the police car. So I'm just giving it as, rather than create, I'll call it as police car arrivals. The entity, we can change the entity here to police car. Here the time given as for the police car, every police car is arriving with a mean of Poisson distribution with a mean of 2 cars per hour. So inter-arrival time will be 30 minutes for one car. So here I'll give it as random exponential 30 minutes. So the units I'll be changing it to minutes. Entity per arrival will be 1. And first creation for the police car, the first car is coming at the 15th minute. So keeping the time units as minutes, I'm giving the value here as 15. So, okay. So there is a possibility of duplicating the whatever the modules we have created. I'll duplicate the same and I'll change the values for the regular cars. So this will become the regular car arrival. The entity, we can change the entity here as regular car. The time between arrivals for the regular car is 11 car per hours with the Poisson distribution. So time between arrivals will be 60 by 11 with random exponential distribution. So the same random exponential distribution I can use, or I can go to the expression and click here as the exponential with 60 by 11 minutes. So this is minutes. Entity per arrival is 1. The regular cars coming at the 0th minute. So I'll give the first creation as 0. Once this is done, whichever the attributes we want to assign, we can use an assign module. So I'm dragging the assign module here. By default, the connection will get to over with the last done module. So I'm removing that connection. So if we want to give the connection, there is an auto connect here, auto connect enabled. So I'll just go and click on this. So the connection is done. So this I'll call it as assigning attribute for police car. One more thing is we have to give the names, unique names, that's or else we get errors here. So the assignment, I'll add here an attribute with respect to the service time of the police car. So the attribute name, uh, I'll give it as service time. That's a user-defined service time. The value here, the service time for the Polus car, we can just check it's exponential 4.3 minutes. I'm assigning that value by right-clicking, build expression, go to random distribution, go to exponential. The mean value is 4.3. So I'll say okay, okay, and this is okay. The same thing, I'll duplicate it. Okay, along with that, before duplicating, I'll also add here, we have to give the priority here for the Polus car. To assign the priority, I'll once again take one more assignment, that's one more attribute, and call that name as it's a sequence, entity sequence. I'll give it as 1 here. This is 1. So now I just duplicate this, get it here, give the connection. So here I can edit here. So the sequence normal cars does not have that priority. It has to wait in the queue. So in that case, I can give the value as 0. Similarly, coming to the service time, here the service time with respect to the regular cars, it's given here as 5.7 minutes. So I'll use the same thing, 5.7 minutes. I'll change the thing. This is for the regular cars. Once this is done, we create the service time here. We use a process module in order to give the service times. So I'll go this, give it as service. So this is the standard module. In order to show with respect to a resource being utilized, we have to use the logic or the action called as cease, delay, release. The meaning is there is a resource by name, a filler or a serviceman. I'm calling here as a serviceman who is being seized by either the police car or the regular cars to do the service, and then they are released. So that's a action, that is seize, delay, release. I've added the serviceman, and the delay type here we have already given previously the service time. I'll take that by using the expression. The units is in minutes. So I'll go to the expression here, right click on the expression, go to build expression. I go here for the special purpose attributes. In that, go for the user defined value and take the service time. So in the same service time, when I'm giving, there is something called as a data definition here, which will have this queue thing. So for going for the service station queue or the service queue, I'll go here. I'll go it with the highest attribute value based on the entity sequence or the service thing. Here also, I'll just check it, change it to highest attribute value. This is entity sequence. Because there we have given the entity sequence, we have given the priority for the police car. I'm taking here. So I'll just click on this, and similarly here, to give different animation effect in the picture for the police car, I'll assign a different value. Let me assign a green ball for the police car, and for the regular car, I'll give a red ball. That means to say a picture red ball is depicting the regular car, police car is depicted by the green ball. This is only for the animation effect. So let me complete this. Once the queuing is done, nothing is given else. So we can just have a dispose module. So connection is done. This is completing the module or the complete model. Now going to the run settings. We can go to the run here, then go to the setup here. In the setup, we have different parameters like run speed, run control, reports. Let me go to the reports and take them rather than the Excel. I'll take the summary report. So that will be displayed on the notepad. So summary report notepad.exe. Similarly, project parameters. This is what are the statistics we want to collect. I'll also enable the processes, entities, queues, resources. Anything you want to change, you can change here. Analyst name, we can give our names here. So replication parameters, the replication length, how much time you want to run the simulation, you can give here. Right now, because they have given us, we have to run for 500 cars. I'm making this as infinite. Number of replication is also 1. There is no warm-up period. So coming to giving this terminating condition, I'll just right click here, say build expression. So here we want to stop the simulation. Terminating for the simulation is when the total number of cars, including the regular and the police car, should be equal to 500. So number out of the police car plus number out of the regular cars should be equal to, there is double equal to here, which means that's exactly equal to 500. This is my terminating condition. So I just give that the base units is minutes. Once I have done all these things, I'll say apply. I'll say okay. Now I'll just run my module. This is for the running purpose. So we can see the green, whenever the green car, it is given the most priority and it is not waiting much, but as well as the red cars, they are waiting. So we are running up to, you can visualize here, it is around 300 cars have come already. So we can increase the speed also, but I fixed the speed here. So I'll be showing it for 500 cars. So once that is done, this is the output. We can see here police car waiting time is 8.703, but regular car waiting time is 232. That is what is expected. And also how many cars have come. If I want to just check, we can just check regular car observation. There are 412 regular cars which have come and 88 are police cars. That can also be seen here. So how many